So, dear students, let me now take up solutions of partial differential equations, and I will begin with Lagrange's linear form. This is known as Lagrange's linear form. Linear partial differential equation. While P, capital Q, and capital R are functions of x, y, z, or constants. If they are constant, then it's very easy. And I have told you in my previous lecture that its solution is given by Lagrange's auxiliary equation dx by this capital P, dy by capital Q, dz by r, capital R. Okay, and you know how to solve such type of equations. Okay, now let me begin with the questions right away. Question number 1. Let me have y square z by xp plus xz cube equal to y square. See, this is pp plus q equal to r. This is xz. So I can write this is of the form pp plus q equal to r. The Lagrange's auxiliary equations are given by dx by capital P, dy by capital Q, dz by capital R. These are equations, and that is why I have written the Lagrange's auxiliary equations are. These are simultaneous equations, as you already are familiar with. So this is dx by P. What is P? P is y square z by x, dy by Q. What is Q? Is xz. And dz by R. What is R? It is y square. Or this is x dy, x dx, y square z, dy by xz, dz by y square. This is one. Now dx by P, dy by Q, dz by R. There are 4 methods. Let me use one. I can take up first 2 fractions together. Taking first and second fraction of 1 together. Choosing first and second fraction of 1 together, we will have x dx upon y square z equal to dy upon xz. See, one of the variables is either present or cancels out. This is our rule 1. This is cancels out. So this is x square dx minus y square dy equal to 0, which gives us x cube by 3 minus y cube by 3 equal to c1. This is the first solution. Say ux y z equal to c1. Again, taking second and third fraction together. No, I cannot take second and third, but I have to take first and third fraction together because y square will cancel. Taking first and third fraction of 1 together, we will have dx upon y square z x, x dx upon y square z equal dy upon z square, y square. What we will get? X dx minus z dz equal to 0, which gives us, this is dz. X square by 2 minus z square by 2 equals C2. This is another solution. So the general solution or complete solution is, see, here we can use C1 as function of C2. This is U. Let me call this U and this is V. U as function of V or V as function of U or function of UV equals 0, or C1 as function of C2, C2 as function of C1, or function of C1 comma C2 equals 0. In both or in each case you will get the solution whatever is the question. So the solution is, let me take up f of say x cube minus y cube comma x square minus z square equals 0. This is the solution. Or you can have x cube minus y cube as function of x square minus z square, or x square minus z square as function of x cube minus y cube. You have, if I will go elimination of the formation of partial differential equation, then this is a this is a function. I have to eliminate f. I will reach out to the original question. Y square z by xp plus xzq equal y square. Okay. Let me take one more question. yzp plus 2x cube equal xy. This is pp plus qq equal r. Let me write down. The Lagrange's auxiliary equations are yz dx by yz dy by 2x dz by xy. This is one. Now taking second and third fraction together, I can choose first and third also. Taking second and third fraction together, we will get dy by 2x equal dz by xy. This and this cancels out. This gives us y dy equal 2dz, or y square by 2 integrated. Y square by 2 is 4z plus c1. So y square minus 4z equals c1. This is first solution. Y square by 2, 2z. So I have chosen y square by 2 instead of y square by 2. I have written y square plus 2z, and this will be 2c1, which is c1 or c2, whatever you like, is a constant. So this is the first solution. Now choosing first and third fraction together, first and third fraction, I will get dx by yz dz by xy. Y cancels out. This is x dx minus z dz equals 0, or x square minus z square equals c2. So you can have, the solution is x square minus z square as function of y square minus 4z, or vice versa, y square minus z square, or y square minus 4z as function of x square minus z square, or function of x square minus z square y square minus 4z. It's your choice how you will write the answer. Either this is the solution, this is the solution, or this is the solution. This we have seen in our previous lecture. Next lecture, next question. Say p minus q, p minus 2q equal 3x square sine of y plus 2x. This you have done in your previous semester also. There's a Lagrange. This is p plus qq equal to r. Lagrange's auxiliary equations are dx by p is 1, dy by q is minus 2, and dz by r, it is 3x square sine of y plus 2x. This is 1. You see, taking first two fractions together, we will get dx by 1 dy by minus 2, or dy plus 2 dx equals 0, or y plus 2x equals c1. This is the first solution. Now this is 3x square, it will combine with this only, so taking first and third fraction together, I will have dx by 1 dz upon 3x square sine of y plus 2x, or 3x square sine of c1 is equal dz using 2 by 2. Now integrate 3x cube by 3 sine of c1. What is c1? Y plus 2x equal to z plus c2, or you have x cube sine y plus 2x minus z equals c2. Now you can have the solution. y1 as function of y2, or y2 as function of y3, or you can have function of c1 comma c2 equals 0. Instead of writing this and this, you can write c1 comma c2 equal 0, or c1 as function of c2, or c2 as function of c1. Next question. P minus q is z upon x plus y. This is pp plus qq equal to r. So Lagrange's auxiliary equations are dx by 1, dy by minus 1, dz by z upon x plus y. This is 1. Taking first two fractions together, you will have x plus y equals c1. Now, taking first and whatever you like, it is up to you now. Second or third, or first or third, you will get dx by 1 x plus y dz upon z. But x plus y is c1 by 2, or dx minus c1 dz upon z is equal to 0. This is rule second. Okay. You can find one solution and then you are using that solution to find the other solution. So this is integrated x minus c1 log z equal to c2, or x minus what is c1? X plus y log z equal to c2. The solution is function of c1 comma c2 equal to 0, or c1 as function of c2, or c2 as function of c1. Next one. Let me take up yz minus x cube yp minus x cube equal to 2x minus 3y. This is it. Now this is pp plus qq equal to r. So Lagrange's auxiliary equations are dx by y, dy by minus x, dz upon 2x minus 3y. This is 1. Now how to solve it? Taking first and second fraction together, we will get x dx plus y dy equal to 0, which gives x square plus y square equals c1. This is first. Okay. Minus x dx, y dy. So x dx plus y dy equals 0 means x square by 2, y square by 2 equals c1 by 2. This is our first solution. Now, you cannot use this solution. So let me use multipliers. This is minus 3y, so let me use 3. This is 2x, let me use 2. And let me use 1. Using 3, 2, 1 as multipliers. Then, each fraction, this is important, each fraction of 1 is equal to, you can see my revisit my video which I have sent to you in first semester. Why this each fraction, you know why is this each fraction is equal. So 3 dx I will get 3x plus 2dy plus 1dz divided by 3y minus 2x plus 2x minus 3y. Since the denominator is 0, so is the numerator. That is 3x plus 2y plus z equals C2. I have taken one step less. 3x plus 2dy plus dz equals 0 means 3x plus 2y plus z equals C2. So solution is function of C1 comma C2 equals 0. Okay, let me take one more question. Let me have, say, mz minus nyt plus nx minus lzq equal ly minus mx. Have you seen this question? Yes, we have discussed this in our first lecture. You see, this is pp plus qq equal to r. Let me write down in that form which I had got in your first lecture. This is ny minus mzp lz minus nxq mx minus ly. This is pp plus qq equal to r. What is the Lagranges? What are the Lagranges auxiliary equation? dx by p, dz by q, dy by q, and dz by r. This is one. Now how to solve this equation? You know, you cannot use rule 1 or rule 2. You cannot take any two fractions. Okay, so let me use x, y, z as multipliers. You know this question. This is x dx. Each fraction is equal z dz divided by x times ny minus mz, y times lz minus nx plus z times mx minus ly. You can see this is nxy minus nxy, mxz, mxz. This is lzy, this is minus lzy. So denominator is 0. With these multipliers, choosing x, y, z as multipliers, then each fraction is 1 of each fraction of 1 is equal to x dx plus y dy plus z dz equal. Divided by this, denominator is 0. Now, so is the numerator. You will get x square by 2, y square by 2, z square by 2 equals C1. This is my first solution. Okay, now let me use L, M and N as multipliers. Let me use L, M and N as multipliers. What I will get? L dx, M dy, N dz, L times, M times, N times. Now you can see this is L and Y. This is it. L and Y, minus L and Y. Minus M L Z plus M L Z. Then M and X minus and plus M and X. So denominator is again 0. What you will get? Using L, M, N as multipliers, you will get L dx plus M dy plus N dz equals 0, which gives Lx plus My plus Nz is equal to C2. Now you can appreciate this because I have shown you that Whether you write C1 as function of C2 or C2 as function of C1 or function of C1 comma C2 equal to 0, you will end up with the same solution. So if you have a question of this type, you will have solution of this type. You can use any solution. C1 as function of C2 or C2 as function of C1 or function of C1 comma C2 equal 0. You have seen that if it is Lx plus My plus Nz equal to function of x square plus y square plus z square, then the solution is given by this, right? If you have C2 as function of C1, then function is this. If you have function of C1 comma C2 function, solution is this. So in each case, so whenever this is P plus Q equal to R and solution is of this type, you know both ways. If you have a function of this type, solution is of this type, and if you have a distance P plus Q equal to R, you have solution of this type, whether this or this. Okay, this is very important. I'll be using it in my future lectures also. Next, let me take up, say, this question you already know. Y minus z, z minus x, x minus y. This is P, this is Q, this is R. P plus Q equal to R. The Lagrange's auxiliary equations are dx by P, dy by Q, and dz by R. This is 1. Now this is very easy, you know. If I will use 1 as multipliers, then each fraction is equal to 1 dx, 1 dz, dy, 1 dz divided by, you have to take z whether small or capital. Whatever you will take it everywhere. So this is xy minus xy minus xz plus xz yz minus yz 0. This gives us first solution, x plus y plus z equals c1. Okay, since the denominator is 0, so is the numerator. You know why? Because I have shown you how this is being done, ratio proportion. Now let me take off this x from here, y from here, and z from here. This will be y minus z plus z minus x and plus x. Choosing 1 by x, 1 by y, and 1 by z as multipliers, then each fraction of 1 is equal dx upon x, dy upon y, dz upon z divided by denominator, which is 0. So which gives us x, y, z equals c2. Log x, log y, log z equal log of c2. So this is it. So you can have c1 as function of c2, or c2 as function of c1, or function of c1 comma c2 equals 0. This is your choice. And you can have a question, say x, y, z equal function of x plus y plus z, and you should end up with this solution, right? Home assignment, this is x square, y square minus z square minus x square minus y square. You have already done this question. So let me take up one more question. Say you have 1 plus yp. This is quite easy and you have done it in your first semester. Q equals z. Pp plus qq equal to r. So this is Lagrange's auxiliary equations are dx by p, dy by q, dz by r. This is 1. Now you can take up first two fractions together and you will get a solution. Let me not show this. This is very easy. For second solution, you cannot take this and this or this and this, and even you cannot use the first solution which you have already obtained. So let me use 1 as multipliers. Then each fraction is 1 is equal dx plus dy plus 1 dz divided by 2 plus x plus y plus z. This is 2. Taking first two fractions, you will get a solution. That solution cannot be used. So another way is that you could have used this and this or this and this, which is not possible. So I have chosen 1, 1, 1 as multipliers. Then each fraction of 1 is equal to this one. Numerator is an exact differential of the denominator. So method 4 is that you can combine 2 with a suitable fraction of 1. So combining 2 with third fraction of 1, we will have dx plus dy plus dz upon 2 times 2x plus y plus z dz upon z. So log 2 plus x plus y plus z minus log z equal log of C2, or 2 plus x plus y plus z by z is equal to C2. So the solution is function of C1 comma C2 equals 0, or whatever you want, way you would like to mention it. Next question. Question is, say, x square minus y square minus z square p plus 2xy q equal to xz. This is pp plus qq equal to r. So Lagrange's auxiliary forms are dx by p, dy by q, dz by r. This is 1. You can now take second and third fraction together. Taking second and third fraction together, what you will get? Dy upon 2xy equal to dz upon 2xz. So this gives us y by z equal to c1. This is the first solution. Log y, log z, log of c1. So y by z equal to c1. Now you cannot use y by z now. So you have to use multipliers. Now using multipliers x, y and z, what you will get? Then each fraction of 1 is equal to x dx, y dy, z dz divided by x times x square minus y square minus z square plus 2xy square plus 2z square. X I have taken common. This is equal to x dx, y dy, z dz divided by x times x square plus y square plus z square. Now this is 2. Now you can combine 2 with a suitable fraction of 1, whatever you like, with this or with this, to get a solution. Okay? Because numerator is an exact differential of the denominator. Choosing 2 with the third fraction of 1 together, we will have x dx, y dy, z dz x times x square plus y square plus z square. X goes 2, you can take over here. This is twice x dx, y dy, z dz x square plus y square plus z square. See, numerator is an exact differential of the denominator, dz upon z. So solution is log x square plus y square plus z square minus log z means z equal log of c2. So log cancels out, this is c2. The solution is c1 comma c2 equals 0. So you can have as many questions as you want, as you wish. You have already done this, so I am done with Lagrange's linear form PP plus QQ equal to R. Next time I will be taking up partial differential equation with constant coefficients. Okay, so do it. Thank you.